Hey guys, welcome back to the channel. So today we are discussing about system calls. So system calls are like an interface that your processes can use to actually access hardware or resources. Now, what do I mean by that? Is, for example, you have a process. That process can either be in user mode or in kernel mode. When the process is in user mode, it cannot access hardware directly, right? So to do that, it needs to make a request or a call to kernel that I want to access certain hardware, right? For example, you want to read from the disk, so you will make a system call, I want to read from the disk, and kernel will entertain that, right? Now, for example, if I add another box over here that says hardware, that will make sense as well, because if you think in a hierarchical way, it is like hardware, then there is kernel running just above it, then these are your processes, right? And they can use kernel as an interface to access that hardware, right? So as I said about read, this is a similar example. Processor reading something from some file descriptor. File descriptor actually is to identify which file the processor has opened. For example, it has opened three files, it will assign three different file descriptor to it, right? And then buffer, then length, how much data you want to read and all, and what is buffer, where to store it after reading, right? So it will make call to the kernel, kernel will process it, it will give back its output, and by that time it is not like your process is suspended. Your process, you will see it as running, but it will switch into kernel mode, right? Now let's see an example. Now here comes the question, why do we actually want to like study this? What is the rationale behind it, right? So there are cases when you are just interested what a process is doing, right? Or if the process is even doing something. For example, you thought a process is stuck, how do you confirm that what it is doing? If it is stuck on a single system call, how will you know, right? So let me show an example. I have a simple code written over here. So it is a simple C++ program. It takes a string input and it's just prints it back to the std out, right? Now if I write strace, and you have to run it with root permissions always to run strace, then you like want to give up, let's say, a process name. I will give a dot out over here because I've compiled it already to a dot out. Now you can see it did several things. Now it is waiting on read. But why so? Because if you have a look at my code, it does something, it prints, then it waits for the user input, right? And this is what exactly happening. As you can see, it did a write over here, write system calls. So all of these are system calls, different system calls. It did a write, several other things before it, memory allocation and all. It did a write, then now it is waiting for a read, right? It want me to give an input. If I give an input, it will do a write back to the std out, which is using one as a file descriptor, and then it will just close the process, right? So this is how it works. Now let's have a look at another slightly complicated example. So let's say you have a web server running, and whenever there comes a request, you want to see what your web server is exactly doing. And it could be for a number of cases. You want to make sure it is working correctly, and you are just, or maybe you are just curious what it is doing, right? For example, I have Nginx running on this server. So if I do grep Nginx, then you can see I have several process over here that belongs to Nginx. First one is the master, then there are some workers, right? Now here comes an interesting thing. If I do strace, let's say only on this particular worker, so I'll do sudo strace, then I'll specify the PID, that is 1759, I'll hit enter. So now I am just tracing the system call for this particular worker. Now what happens if I make a curl and I make a curl call to it? You can see something happens over here. It is waiting, actually it is now waiting for another request to come. It is actually polling, waiting for a buffer to actually, that buffer is actually what contains the request. Whenever user makes a request, it will be placed in the buffer. Then from buffer, these any of these worker can consume it. It is like a producer consumer thing, if you are aware of it. Simple. We put request in a queue, any of the worker can pick it out of these four. If I make a system, if I make a curl call again, then yeah, these will reflect over here. Now what if I attach it to a different worker? Let's say I attach it to 1765. Now if I make a call, it is reflected, but as I made the second call, the second one was not reflected over here. Now why so? Because all of these workers are listening on that queue, right, for the request, and they want to serve it. Now, let's say there is a request which 1759 picked as soon as it is there. So what will happen? 1759 will serve it, but not 1763, 1764, and 1765. Right? That is what happening with 1765. When I am doing stress on this, then only some of the calls will be served by this. All of these might be served by any of the other threads. Now, in cases like this, you might want to attach stress to several different processes. So you can specify more than one PIDs over here. You can do something like 1764, 1763. And now if I hit enter, I am doing a trace on all of the PIDs. Now if I make curl, then I can trace system calls on all the PIDs. And there is another this descriptor over here to show which log came from which PID exactly. And all of these are system call. For example, if I pick this ePol, then I even searched for it already. Just a second. So it will load it. You can see the system call that waits for some event to happen on some file by file descriptor, that is EPFT, right? And as soon as that event happens, your process can take action, right? So this is how it works. You make a system call to kernel, you let the kernel process it and gives back an output to you, right? So this is what system calls generally are. Thanks a lot for watching the video, guys. I'll see you in the next one. Thank you so much. Bye bye.